Good evening, everyone. Your instructor will join in 3 to 4 minutes. So wait for that and let others also join. Then you will start with that. So how many of you have already presented your project?
Say group 1
Okay,
and group 2 also have presented yesterday.
So group two
okay, okay.
also.
Okay, so few students are left with the presentation, I guess.
Yes, sir.
Okay, then just wait for 3 to 5 minutes. Okay, then we will start.
Hi guys. So we'll just start off in just 1 minute. Allow me 1 minute, please. We'll just start in 1 minute. Okay, guys. So from group one, whoever had left with doing the details, are you people done?
Yes, ma'am.
Okay. I just need to see the details. Can you just share me the details?
Oh, yeah, sure. Can you see my screen, ma'am?
Yeah, I can.
Okay. So this is my GitHub, and they're all the 5 week project.
Okay.
And yeah, do I need to open each of them?
No, no, that's fine.
Okay. So, and here is all the 5 week or 6 week collab, and I can show you the mail as well.
Okay.
Yep. Here all the 5 week GitHub repository along with the collab file and video link.
Okay. Okay, Arun. Yeah. Thank you.
Okay. Thank you, ma'am.
Yeah. So, for group one, there is Lakshya also. You are left with doing the details. Have you done? Arun, is Lakshya here in the meeting? Because I can't see him here. Can you just ask him to join and just confirm me with the details?
Yeah, sure. Just give me a few seconds.
Yeah, yeah, that's fine. You can take your time. Next is Isha. Isha, sorry, someone from group two was left. Just a moment, let me check. Yeah, Isha only, I guess. Isha from group two, you are left with doing the details. Have you done?
Yes, ma'am, I've done. I can share
Yeah,
my
just
screen.
show me the details, please.
Yeah, ma'am.
I can't see your screen.
Ma'am, now is it visible?
Yeah, it is visible.
Okay. Ma'am, here's a for week one, two, three, week three, four, and five projects along with video. I can show you.
Okay. And where is week one and week two?
Yeah, ma'am, already submitted.
So have you have mailed them as well, right? Group
Yes,
one and
ma'am.
group two.
This
Oh,
is
sorry, week one and
week one, and this
week
week
two.
two, and week
Okay.
three, week four, and week five.
Okay.
And this is my
Uh,
GitHub.
just share me the details of week one mail. I just want to see that once.
Yes, ma'am.
This one, right?
Yes, ma'am. Ma'am, I have
Oh,
presented the presentation session already, so there's
okay.
no video of week one. And week two, I have uploaded the along with the video. Sorry, this is week two,
Okay.
and
Week two, you
this
have a
is
video, right? You haven't
yes,
presented
ma'am.
in the session.
Yes, ma'am.
Okay. Okay.
And this
Okay.
is week
Got it.
three, a video link and this collab.
Okay.
And week four, this is the project four, and then projects five
Okay.
one with video link and collab file, ma'am. Here.
Okay. Okay, Isha.
Also,
Just
I
show me the
submitted
GitHub once.
week one, project one, project two, and project three, and project four, and project five here.
Okay. Okay, Isha. You can just stop your screen sharing.
Okay, ma'am. Thank you.
Yeah. And I just wanted to update for group one and group two, you are already done with the presentation. So any one member from your group can share the final project details in the mail. Along with that, can share the details. Like any one of you can just do that. Aditi, Aryan, any one of you can try and do that. Just inform me who have shared the details to the mail. Fine? Is it clear, guys?
Yes, ma'am. Yes, ma'am.
Yeah. And same for group two. Any one of you can just share the details like the group six, like the week six final week project that you have already presented. You can share that in the mail, but make sure that you share the entire project details, like the collab file details, along with the PPT and the report in the mail. Okay?
Okay,
And
ma'am.
just inform me that who have shared the details in the mail. Fine?
Okay, ma'am. Okay,
Means,
ma'am.
ma'am, any one of the group members should share it.
Yes, yes. Okay, just
Okay.
mention me from your group who have shared it. Fine?
Okay, ma'am. From group
Yeah.
one, I'll be doing it.
Okay, Aditi, that's fine.
Yes, ma'am.
Yeah, Ran Vijay, what is your issue?
Very good evening, ma'am. Actually, I have one
Yeah,
issue, ma'am. I
yeah,
have everything done, ma'am, but the deployment part, ma'am, we are doing. Just we are getting the
yeah.
link to local host, but we are learning it's
Mm-hmm.
coming to error. Nothing is coming in my schedule. Ngrok we are doing and Streamlit everything we are doing.
Uh,
This is getting the we are getting
try
the
and yeah,
link.
try and use ngrok. Yeah, use ngrok. I guess using ngrok that will solve your issue. Have you used ngrok?
Yes, ma'am, I'm using the Ngrok
Okay.
Streamlit. We are
Then
getting the
I
link,
need
but
to
the link
see
is
it,
not
right?
working.
Without seeing, I can tell you the details. But today is the presentation session. Other teams and other groups are waiting, right? So I can't
Okay, ma'am,
just,
no problem. No problem. Finish it last time
you can just
in the last take.
drop me a text and show me the details up later. Yeah, after
Okay,
the
okay,
presentation,
ma'am.
all the session is bit done. Then you can show me. I
Uh-huh.
can try to help you. Fine?
Okay, okay, ma'am.
Yeah. So
So
group
where I
four.
drop the message? In you in WhatsApp where?
Uh, no, I told you that you just wait for some time in this session. Like
Okay, okay,
after the end
okay,
of the
okay,
session, I can see
okay,
because other teams are waiting, right? This is the presentation
okay,
session is
okay,
going, right? You need to wait.
okay, okay, no problem. Yes,
Yeah,
ma'am. Yes, ma'am. Yes, ma'am. Okay.
fine. Yeah. So yesterday, group four was telling they want to go first. So,
Yes, ma'am.
right? Okay.
Yes, ma'am.
So, guys, you'll be given with 30 minutes of time. Try to convert all of the details like the presentation, the PPT, along with the report, all of this in 30 minutes, right? You don't have to go
Ma'am.
in really deep, but just make it in that form. Yeah.
Okay, ma'am. We will keep it short, but I have to mention one thing that one of our member, that is Adnan, is not here because he is in
Mm.
the hospital because of some emergency.
Okay, what
But
happened to him?
ma'am, not him, but one of his family member is admitted in the hospital.
Okay, okay. So anyone of you are taking
Yeah.
his part, right?
Yeah, ma'am. Actually, his part was deployment. We will not
Mhm.
explain it, but we can explain the UI part. Is it okay?
Sorry, I'm not getting you.
Ma'am,
I'm not getting you.
his part was deployment,
Uh-huh.
but
Okay.
one of our member will explain the UI part after deploying. We will show you how to deploy and we will explain the UI part. Is it okay?
Okay, but a major thing is that like if you people are going ahead and one of your member is not available or not going, then he will not be included, right, in the group because he have done all of the work and he is not there in the presentation. Then how we can conclude up? So, guys, can you just wait for some time? By the time group three will present, I'll just take the confirmation. If that is allowed, you people can go ahead. Will that be fine?
Ma'am, actually, one of our member Chetan is in between a hackathon and he has mentioned that he has managed to get some time for this presentation. That's why we asked you yesterday to let us present first.
I understood, but this issue was not there, right? So I can't just go ahead because one of your member who has actually put in efforts is not there in the session, like is not available. I know there might be an emergency, but this I am not like authorized. I need to have a discussion. Okay, then just give me
Okay,
2 minutes
ma'am.
of time. I am just checking on, and based on that, I am confirming.
Okay, ma'am.
Okay, fine. So group four guys, you can just start off with the presentation. Okay, with the four members.
Okay, ma'am.
Yeah.
I'm
And
sharing my
after group,
screen.
yeah, just a moment. After group four, group three, you people will start off. So you just have a discussion among yourself, and after them, you will be presenting. Fine, guys.
Okay, ma'am.
Yeah. So, guys, you can just present your screen and start with the presentation.
Okay. Can you see my screen?
Yeah, I can.
So, good evening, everyone. I am Dikshant Ranjan from group number 4, and my team members are Adnan, Chetan, Dikshant Sharma, and Dhanushi. And I am going to present our final week presentation titled Generate Synthetic Medical Diagnosis Record. So, the project mainly focuses on generating synthetic medical records, which is realistic looking fake records to train machine learning models. It is built to help doctors and healthcare industry to build, test, train, and improve medical predictions tools without breaking privacy rules. It uses machine learning algorithm. It is it is to find patterns and health conditions like asthma, cancer, hypertension by using the data like test results, medication, age, and etc. Talking about the business context. Uh, in the healthcare industry, sharing and using real patient data is very risky due to privacy rules. So, generating synthetic data allows healthcare industry to develop and test AI models, train new staff, and share data safely with researchers or partners. Uh, Talking about the data overview and data preprocessing. So in the data set, we have details like patient details like name, age, gender, blood type, medical information like medical condition, date of admission. In administrative details, we have doctor, hospital, room number, billing amount, and etc. For data pre-processing, we have followed some steps to clean and prepare it. These steps are standardized column names, clean text fields, converted dates, handling missing and data and duplicates, engineered features like we have created columns like length of stay and age group for the better prediction. You can see here the key processing steps and model techniques that are data loading and exploration, data wrangling, synthetic data generation, data augmentation, visual comparison, hypothesis testing, supervised learning, unsupervised learning, and model deployment. Uh, for evaluation matrices and business impact, evaluation matrices we have used for regression models. We have used mean absolute error, root mean square error, R2 score accuracy, and for clustering models, we have used actually Silhouette score, Davis Baldwin index, and CH score. Talking about its business context impact, so the ability to generate and use synthetic data has a significant business impact, like reducing privacy risk, accelerating development, improving data sharing, and cost saving. This all helps us to this all helps us to in business very significantly by speeding up the innovation in a low cost. Now about my part, like about data set. So I have already shown you the data set. What is the part here? You can see a brief about the data set. Like in the patient, we have name, age, gender, blood type. Uh, these are the medical informations, hospital and billing details. And now, what the problem statement? The project mainly addresses the difficulty of using real patient data for developing healthcare AI systems due to strict privacy regulations. The limitation may basically works as a barrier for the progress of medical research and the development of effective diagnosis and predictive tools. To overcome this challenge, we have created the project that mainly aims to create significant medical diagnosis record. These synthetic records are designed to mimic the statistical characteristics of real patient data without containing any sensitive information. This allows the researchers to train and test their models without breaching the privacy policies. Now let's begin our with our code. I have imported some of the libraries like pandas, numpy, matplotlib, and seaborn for visualization. Here I have loaded the data. Now I have actually I have copied the data in a DF, that is a data frame, and also in a also copied it in a another data frame, that is DF clean, and I have converted all the columns into list for just for showing. Uh, Now here I have printed the shape of the dataset by using the df.shape. You can see there are 55,500 rows and 15 columns. And here I have printed the information of the dataset by using df.info. You can see there are the number of columns, the name of the columns, any null values, and what are the data types are. Now I have also printed the summary statistics by using the df.describe, where I have printed some of the count, mean, and standard deviation and other statics value of age, billing amount, and room number. You can see the count is 55,500 for age, and that's all. Now after that I have deal with the missing values by using the dot is null value. You can see there is no null value in any of the column, and here I have printed the total number of missing values, which is also 0. Then I have duplicated. I have printed the number of duplicate rows, that is 534. You can see here I have printed some of the duplicate rows. These are the duplicate rows. Now this is just a brief about the data set, about the shape, that is 55,500 rows and 15 columns. The data types, what are the data types are like numeric, we have age, billing amount, room number, and object like name, gender, blood type, etc. Duplicate values are 534, and there are no missing values as already mentioned. Now moving to the next part. So here I have again I have printed the shape, converted the column into list, and printed the info just for showing it to you. Mm. Now here I have printed the unique values per column. How many unique values per column I have, and this code prints the column where there are less than 10 columns. You can see here, like in gender they are male and female only. In blood group they are B negative, A positive, A negative, O positive, AB positive, and so on. These are all the columns that have less than 10 unique values, and these are the number of total unique values in every columns. That's all from now. Dikshant Sharma will carry his next part.
Hello, am I visible? Uh, Hello.
Yeah, your screen is visible, Diksha.
Uh,
Yeah, your screen is visible.
okay, okay. Hello everyone. I will be walking you through my project on a part which is data wrangling, also called data manipulation, synthetic data generation, and data augmentation, using our healthcare data set. In simple term, my main goal was clean the original data, generate new artificial data that looks realistic, and compare how both behave using some visualizations and model. The first part was data wrangling. I first started it by importing the main library Panda, which is used for handling and cleaning datasets. Uh, I have done this loaded. We have loaded the healthcare records into a data frame called DF. There are some steps in this, like I have done standardized column names. I have cleaned the text fields. I have converting the dates. I have handled missing and duplicate values, feature engineering on the basis of length of stay and age group, and the final check. In this final check, I printed DF info and DF head, which to check the first few rows of our clean data set. At this point, we know that the data was standardized, cleaned, and ready for analysis and modeling. My next step is synthetic data generation and data augmentation. So we have already cleaned our data. The next big step was to create synthetic data. Basically, fake data which can be used as a realistic data, which can be used as the same statistical patterns as the real one. Synthetic data can be used or is very useful when we want to test our models without using sensitive real world data set. Our my first step was pre-processing. I again loaded the same data set and cleaned the columns. Then I used a label encoder to convert the text columns. Uh, Next, I filled the missing values using the median value, and this is because there are outliers in our data. Finally, I printed that data set shape to the confirm how many rows and columns do we have. Next is this data synthetic data generation. I created a new data frame called synthetic DF. For these, I generated random number based on each column. That basically means that synthetic value behaves like the original one, but it is not the exact copy of our original data. Step third was data augmentation. After generating the synthetic data, I also did data augmentation, which means that adding a bit of control noise to our data, so it can be modified. It can be made into modified copies of existing data. For each columns, I added a very small random noise, about 1% of the standard deviation. It actually helped me in extending the data set and making learning model more generalizable. Then I combined the original and augmented dataset using Python. Combined dataset shape is this. Next, the third part is visual and comparison. Now we had our real data, synthetic data, and augmented data. I moved on to visual comparisons to see how similar they are. Our first graph is distribution comparison billing amount. In this plot, this blue curve shows the original data set. The orange curve shows a synthetic data set. And the x-axis represents the billing amount, and the y-axis shows the density or how frequently our billing value appear. Both curves have almost similar shape, which means that our synthetic data and our captured data in the same distribution shows same pattern. Next is our correlation heat maps. So we have two heat maps, which is for one for original correlation and one for synthetic correlation. Each square in this heat map represent how strongly these two variables or our two variables are related to each other. Like blue shows low correlation and red shows high correlations. And this heat map is for synthetic correlation. Our next plot is pair plot for age versus billing amount. The third visualization shows the original and synthetic data points. Blue dots represent the original data, and orange dot represent synthetic data. Uh, we can clearly see that both sets of the point overlap quite a bit. That means that synthetic data falls in the same range and pattern as the real data. Next is model comparison. We have confirmed that the data looks similar. The next step was to train the model on each data set, the real data, synthetic and augmented data, to see how they perform. So I use a linear regression model to predict the billing amount using features like age, gender, and blood type. The R square basically tells us how well our model can predict the target variable. Higher the R square value, the better accuracy. In our results, R square shows for real synthetic and augmented data were almost so same. That's actually a good thing because it means that synthetic augmented data are realistic enough to train the model, and it performs similar to the authentic or original data set. These are our insights on synthetic data generation and data augmentation, like distribution similarity, correlation, structure, and model performance. Next part will be presented by Dhanush.
Is my screen visible, ma'am?
Yes, it is visible.
So I will be continuing with the EDA graphs. So why EDA is important to analyze? Like we don't know how the variables are correlated. To know the relation between the each variables, how they are related, we are going to use the EDA graphs. So first we have been standardizing the data set which present by removing the lower, like we are converting the uppercase to lowercase and we removing the space and converting the dates in this. We are like calculating the stay like from the date of admission and the discharge date. In first graph, we can see the age distribution, like at what age the total number of patients have been admitted to the hospital. We can see the higher bump in the middle age of 40 to 60 means the age of 40 to 60 people have been admitted more. The gender count. It will shows the like between male and female the how many people have been admitted to the hospital as a patient. We can see both are like similar around 25K plus. Blood type, every person has different type of blood and it shows the data sheet shows which blood group has how many count of the patients they have been, and we can see almost every blood group have the similarity of same, but there will be just a slight changes. This is the billing amount. The patients who have been joined to the hospital and their billing amount, it certainly reaches a particular. So like it will be the count at particular rate how many have been billed this much like that. This is the test result frequency. It has been divided into three part like abnormal, normal, and inclusive. So it will give the count of the three division part of each patients. It will be the insight of univariate analysis. Now we move on to the bivariate. It will give the distribution of age versus billing amount at particular age, how much it has been built. We can see that at lower age there might be a billing amount will be less or it may be high. It doesn't depend upon the amount doesn't depend upon the age, depend upon the like how they stay and their treatment cost. This is a box plot of the male and female at an average of billing amount. So the mean value both are at 25K. It is a admission type and the billing amount. In the admission type, I have been divided into three type like urgent, emergency, and elective. So if they are admitted at the like urgent, like and more emergency like that, it is we can see the mean of 3 is at the same line. It is the age of and length of stay at particular age patient how many days they have been stayed in the hospital for the treatment. We can see that uh, the age doesn't depend upon the length of the stay. It might be depend upon the it might be depend upon what the patient's reason and the like that. And Grafton shows the insurance provider, which company provided the average insurance amount for the patients so that they can pay their bill amount. These are the insights of the bivariant analysis. Now move on to the multivariate analysis. Here we are comparing the three major variables: gender, age group, and billing. So we can see male and female, which has been separated by box plot and the billing amount. So the age group are divided into child, youth, adult, middle age, senior, and elder. The mean of between the male and female just varies later at particular age. This is the correlation heat map. So it shows the correlation between age, billing amount, the room number, length of stay, like that. This shows the admission type and length of stay, means at what stage they have been admitted, and the like the gender and how many days they have been stayed in the hospital for the treatment. This give the like insight about the patient is gender, patient of their gender, male or female, and what disease they have been facing, and the billing amount. We can see the asthma as the higher the billing amount, and obesity in the medical condition. This is pairwise relation, like the age, billing amount, and length of stay, and the gender of male and female. Some of them have been data. The some of the data point have been overlapped each other. We can see in this. Now let us move on to the interactive EDA part. Here we can see by dragging our cursor. So as we seen previous, this is the age distribution at particular age, like how many have been joined the count. This is the total number of male and female who have been admitted. So we can see there is just a slightly some amount of changes. This is the blood type distribution, like in the hospital, the patient who have been joined and their blood type which has been distributed. We can see almost everything is similar. A negative has some 0.1 is slightly higher. This is here we are going to see the graph plotted against stage versus billing amount. We can see the gender male of age 42 and their billing amount and the medical condition and insurance provider, which company provides the insurance. This is the admission type and billing amount. uh, During the emergency or urgent or elective, we can see median it is almost similar to 25. There will be just a slightly changes in points. These are the insurance provider, the companies who are going to pay the bill amount as the insurance. Every company provides almost the same amount of the insurance money. This is as we seen before, it is like the medical like what age people have been stayed this long in the hospital for the treatment. We can see the medical condition cancer at age of 45 they have been stayed for 18 days. In this we are going to see the relation between gender, age, and the billing amount. The age group has been divided into youth, middle age, and adult, and the median will be same as 25. Just there will be a slightly changes when compared to each other. This is the correlation heat map, which shows the red value shows the positive and the blue shows the negative. The next hypothesis will be taken by the Chetan.
No, I can't see your screen, and your voice is also not audible properly. Yeah, it is visible, but your voice is not properly audible.
Is it also audible now?
No, not
Is it audible
properly.
now?
You need to speak a bit up. It is audible, but you need to speak a bit up.
Okay, ma'am.
Okay,
So
you can
now hypothesis
start.
testing. So the main goal here is
Uh,
to
your voice is breaking,
statistically
Chetan,
verify
and not properly audible. So you need to be a bit higher. Like your voice needs to be a bit
whether
higher.
certain features are instruments. So is it audible now?
Yeah, it is
Hello.
audible now. Yeah.
Okay, now we move to the hypothesis testing part. The main goal here is to statistically verify whether certain features in our data set have a significant relationship with the diagnosis outcomes. So we start off setting up the hypothesis, the null hypothesis. There is no significant difference between groups or no relationship between the variables. And the alternative hypothesis, there is a significant difference in the difference or relationship. Using statistical tests like t-test and chi-square or ANOVA, we calculate p-values. If the p-value is less than 0.05, sorry, 0.05, we reject the null hypothesis and accept that the difference is statistically significant. This step helps us to understand which feature truly impact diagnosis outcome rather than just relying on correlation visually. So uh, this is the t-test. T-test is a statistical method used in hypothesis testing to determine if there is a statistical significant difference between the means of two groups or between the mean of single group and known value. So here we got the test result. Mean billing amount was for males is dollars 20 to $25,600, and for female it is 25,470.65.
Uh,
The
Chetan,
statistic
did your
which we got
screen got
is
stuck? Because I can only see
1.13.
this T test section. I can see. Is your screen stuck?
No, ma'am, I'm scrolling.
Can you just scroll it down now? I
I'm
guess your screen has
scrolling, ma'am.
stuck. Because the screen has stuck some in between. I can only see the T section, like the T test, that part.
Is it visible, ma'am? Now?
No, not yet. No, not yet. Yeah, now it is visible. Just wait for some
So,
time because it takes
now,
time. It is not visible now. Wait, I'll tell you when it is visible. Just don't stop sharing. Just allow some time to take on. No, I can't see your screen. Your screen is. You can ask any of your group member to present on behalf of you, and you can just explain on that. Yeah, now it is visible, Chetan. Just
is it
scroll it down.
scrolling? Like I'm scrolling it. I'm scrolling it.
No, I am not getting. Only ANOVA test I can see, but below that I can't
Yeah,
see.
I will ask someone to present, ma'am. Sorry. Sorry for
Yeah,
the
yeah, that
interruption.
would be good. Yeah, it's fine. You can ask anyone to just present on behalf of you. Yeah, Dhanush, I can see your screen. So Chetan, you can start off.
Okay, ma'am. So an ANOVA test is a statistical method used to determine if there are a significant difference between the means of three or more independent groups. You can scroll down. Scroll down. In the ANOVA test result, we got F for statistics 2.1592 and p-value which is 0.0556, which is greater than the 0.05. So conclusion failed to reject H hypothesis. No statistical significant difference in mean building amount. So next is chi-square test. The chi-square test is statistical used to analyze categorical data comparing observed frequency with expected frequency. Can you scroll down? Dhanush, can you scroll down? In this, we can see the rate where medical conditions where asthma, cancer, diabetes, hypertension. Here, the abnormal values and the inconclusive and normal values. Here we got the p-value which is 0.2098. Again, it is greater than the value. So we
Chetan,
again
your
failed to
voice was
reject
breaking in
hypothesis.
between. Your voice was breaking in between. Sometime it is
Sorry,
breaking.
ma'am. I'm actually at a hackathon, so
I understand, but this is also your,
not at
since you are presenting, you, it should be a proper, right? I understand that, but this part should be also
yeah.
like proper. Okay, you can continue.
Sorry, ma'am. So
Chetan, you can continue.
okay, ma'am. The supervised learning. After identifying significant features, we move to the supervised learning, where our goal is to predict the diagnosis using known label data. We split our data set into training and testing sets and train models and evaluate their accuracy. We have used logistic regression or decision tree or random forest. Each model learns from input features and predicts whether a patient belongs to a particular diagnosis category. So, sorry. Uh, okay, this is the plotting of each model which we have used: linear regression, decision tree, and random forest, gradient boosting, X, G boost, and etc. Can scroll up. Yeah, this is the model accuracy comparison of each models. Here we got more accuracy in random forest. So what we can observe from both supervised and unsupervised learning is so overall, starting from hypothesis, we identify significant features. And then through supervised learning, we build predictive models to classify diagnosis outcomes. And then finally, using unsupervised learning, we explore natural grouping for data. So this combined steps gives us both explainability and predictive power, ensuring our synthetic medical records are useful and reliable for the future research. I'm done. Sorry for the interruption, ma'am. Sorry. Really sorry.
Okay, but you continue.
Ma'am, I will be continuing the Adnan's part, the
Okay,
deployment process.
fine, fine. Okay, fine.
So first we have been installing the Streamlit and PyNGork. So we are importing the data set and we are checking the like which are the column present and importing the model of a random forest, and we are training the model based on our data set by training and splitting it, and we are scaling the numerical values. This is the app.py. Here we are creating the models, scalars and column encoders. This is the ngork. We have been giving the access to the ngork by using the auth token. So when we run the app, we can see the Streamlit UI user interface. We can use the age, billing amount, and the test result. It will be either inconsol or abnormal and normal, and the gender, male or female, and the blood type. We consist of many blood types, and based on the admission type, it might be emergency, elective, or urgent. And the medication, it might be anything. We can predict the what kind of disease the patient consists of. It is arthritis. If we can change the blood type and we can see, it will be like hypertension. This is the user interface we have been created. We can change the age and the billing amount and the emergency medications and all. We can see the predicted medical condition of that patient based on the what we give the input in the dataset. It has been present. And this is about the user interface.
Yeah, Dhanush, can you just change some of the details over here and can show us one about the
Yes,
user
ma'am.
interface?
I can. It is basically first it is hypertension. I'm changing the so
To change the age parameter and next
yes,
what
ma'am.
parameter you're having? Yeah, billing amount that you can just drop off a bit. Yeah,
It is obesity.
okay, okay, fine. Okay, you can just stop sharing the screen. So who wants to go ahead with the PPT presentation and the reports?
Ma'am, I will be going with the PPT, ma'am.
Sorry, I just missed out. Your voice was not audible. Can you just confirm me once?
I will be doing PPT and Deekshant will be doing the report.
Okay, fine. So you can go ahead.
Yes, ma'am.
Yeah, it is visible. You can
Yes,
start.
ma'am. The topic is generating a synthetic medical diagnosis record. So the project overview is we have been taken the healthcare data set from the Kaggle, and we are being training using the machine learning model of random forest, and based on that we are developing a streamlit interface which explore the data and model training, testing and visualization, which create the user interface of the variables which has been present in the dataset, and we are going to predict that based on the variables what is the patient's disease. The main objective and the goal is to develop a end-to-end pipeline which create a realistic synthetic medical records by using the dataset, which is allows to diagnose and safe experiment and machine learning model training without using the real patient data to ensure the privacy. Methodology, we have been data pre-processing, data generation, synthetic data generation, data augmentation, statistical validation, model selection, and deploying the Streamlit app system features. What are the features required to our system? It is like single record prediction. The system offers a interface for entering individual patient parameters and to instant risk scores and predict what is will be their their disease, and so that the visual feedback we can give. So the expected outcome, it will be like when we select and drop down the age and amount, it will be show the what will be the clinical disease based on the parameters which have been given. This will be the visualization like flowchart. First the data collection, we have been pre-processing it, we have been modeling and choosing the right model, developing Streamlit UI, and we are going to predict what will be the disease. This is the working. Thank you. Dikshan will be continuing with the report.
Yeah, Dikshant, it is visible. You can start.
Yes. Uh, First is opening cover. Hi everyone. This is our final internship project for AIML internship at our project title is generate synthetic medical diagnosis records. It is submitted by MD Adnan Kesa, Dikshant Ranjan, Chetan, Dikshant Sharma, and Dhanush. Here is the second page certificate. Then acknowledgement, abstract, table of contents. We will be covering these points in this report. Next is the introduction. The healthcare, we know that healthcare sector generates a vast amount of data set every day. Patients' admission, their tests, results, billing, insurance information. And doctors and hospitals often struggle to make sense of these data quickly. So our main idea was to design an intelligent system or ML model, machine learning model, that could take in simple patient data and suggest what possible medical conditions he's facing. This could possibly save time and also reduce diagnostic errors. Here's our problem statement that I have already explained. Our objective of the project to design an intelligent ML model capable of predicting patient medical condition to pre-processing and clean healthcare dataset for high quality input. Our next point is literature review and the background study. When we started, we looked at how ML is already being used in healthcare. We have used algorithms like random forest, gradient boosting, and neural networks, clustering techniques like K-mean and DB-scan, system architecture, the data source, pre-processing, modeling, evaluation, and deployment. Tools and technology use, we use Python, we use libraries like skitlearn and XGBoost. For data handling, we use Panda NumPy. Visualization, we use Matplotlib, Seaborn, and Plot. And for web framework, we use Streamlit, deployment, ngGo, Google Colab, VS Code, and GitHub. Here's our module and feature description, like what each does. Data processing module, synthetic data generation module, model training, unsupervised learning module, model evaluation, deployment. Here's our database design, front end and back end review. In this front end, in the back end, like we know that back end is the brain, or it is the heart of the project. We use Python to handle all the data processing and model operations. For front end, we use Streamlit. We built a clean interface with drop downs and sliders for age, gender, medication, test results, and predict its and the backend predict what actually might be facing. Here's the implementation point: data pre-processing, model building, clustering and visualization, deployment. Here we can see the test cases and results. We can conclude that the random forest classifier performed the best, offering a balanced accuracy around 65 to 70%. Here comes the next part, deployment process. We made the project live using we have already shown in our project. Here's a limitation of our project. Dataset is very limited and may not represent all real world cases. We didn't include genetic or temporal data, and the model accuracy depends on input data quality. What can we enhance in our future? What are the future enhancement? We can add more health parameters. We can use deep learning. We can expand our data set, train model on new data set. We can do cloud or mobile development or deployment. Conclusion, the to wrap up all of this, the project showed how machine learning can make healthcare data set more actionable by generating synthetic data, cleaning and training models. We and deploying a working web app. We built a full AI model from start to finish using random forest model, which delivered the best balance of accuracy and reliability. Here are some snapshots of our code, heat map, correlation heat map, pair plot, and some screenshots of EDA. Here are some snapshots of our UI, our deployment part. That's all about.
Okay, Dikshan, just go up in the code, like in the
Yes, ma'am.
report, just go up in the first page.
First page.
Yeah, the first page. Just go a bit down, a bit down. Yeah, what? Okay, fine. Got it. Okay, okay, got it.
Okay,
And
ma'am.
just wanted to ask you about like in GitHub, have you all uploaded the project up?
Yes, ma'am.
Yes, ma'am.
Okay. So there, try and add the snapshot of the like the website that you have created, the interface. The that part, like after it is actually giving you the prediction, like before the prediction and after the prediction, whatever be the changes you are making, just add 2 or 3 snapshot of that. Right?
Okay, ma'am.
Okay.
Okay. Fine. You can just stop sharing your screen. Now, guys, I'll just call you people one by one name of you. Just show me the details of your GitHub and also the mail that you have shared of the rest week 5 till week 5 the projects. Right?
Okay, ma'am.
Uh, Dikshant Ranjan.
Yes, ma'am. Can you see my screen, ma'am?
Okay, just want to know. Yeah, now it is visible.
Yeah, ma'am. This is my mail. This is my first week. I have not presented, ma'am. Actually, I have exams in college, so I have
Okay.
uploaded the video, however.
Okay. For all
And
5,
this is
right?
my get. Yes, ma'am.
Okay.
This
Okay.
is my second
All
week.
okay.
The third one,
Okay.
and the fourth one, and in
Okay.
the fifth, ma'am, I have presented the during the session.
Okay, fine. So you have shared the GitHub link, right?
Yes, ma'am. Now
Oh,
these are my in the repository. Low analysis is my first week. Then I have done the
okay.
credit card fraud detection. Then customer segmentation,
Credit card fraud
patient
detection. Okay.
patient clustering, and then heart disease prediction.
Okay, fine. Got it. Fine. So you can just stop sharing the
Okay,
screen.
ma'am.
Yeah. Just wanted to ask, just wanted to give you the information, from your team, like, since it's been done, the presentation has been over, any one of you can just share the final week project details, the project collab file details with the report and the PPT in the mail ID that where you are actually sharing your other details, like the week till week 5 projects where you have shared, you can share any one of you have to share, and based on that, just make sure that you add all of your group members' name. Fine. Make sure
Okay,
that
ma'am.
you add all of your group members' name. Fine.
Sure.
Okay. And next is Dikshant Sharma. Can
Yes,
you
ma'am.
just
I will.
show me? Yeah. Okay.
Here's my GitHub link. My first project was Olympic medal analysis. Second week was diabetic
Okay.
risk analysis. Age spending cluster third week. Fourth, student performance. And the fifth was credit card fraud.
Okay.
And these are my email project. I have uploaded or I have sent link of video, PPT video for first week and second week in a Google Drive.
Okay. So for
And
first week and second week, you have presented in the session?
no, ma'am. In first week and for first week and second week, I uploaded a video of PPT.
Okay. Okay. First week and second week, you have given the video. Okay. For
For
third week?
third, fourth, and fifth, I have presented here in the meeting.
Okay.
And these are my emails. And submitting. I have submitted all week projects.
Okay. For third, fourth, like third week, you have presented in the session. For the fourth
Yes,
week?
ma'am. For third, fourth, and fifth. I have presented for third,
Sorry.
fourth, and fifth.
Third, fourth, and fifth, you have presented in the session.
Yes, ma'am.
Okay. Okay, Dakshant. Fine. You can just stop sharing. Next is Dhanush. Dhanush, can you just share?
Yes, ma'am. Is it visible?
Yeah, it is visible.
Dark web is the week one project. Investment portfolio week two. Customer segmentation week three. Climate data clustering week four. Skin disease week five. And generate medical diagnosis week six.
Okay. Okay, Dhanush. And the mails?
In mail, I have done presentation first and third week in the session.
Okay.
2, 4, 5 have been attached the presentation video.
Okay. Okay, got it. Fine. Okay, Dhanush. You can just stop sharing your screen. Chetan, you are here?
Yes, ma'am. Yes, ma'am.
Yeah. Can you just share the screen and let me know the details, please?
Hmm.
Is it visible, ma'am?
Yeah, it is visible. You have switched to WhatsApp.
It's an email.
Now, like previously, you have switched to WhatsApp. Now it is mail. Now it's fine. I can see it now.
This is my first project, first week project.
Okay.
This is second week project which I submitted.
Just a moment, because I can only see the first week. The second week, the screen is not coming up with the second. Just show me the second one once again.
Second week.
Not visible in the screen. Okay, yeah, now it is visible.
This is the third
Okay.
week.
I can only see the second week now. Yeah, now it is third week. Fine.
This is fourth week.
Okay, just hold, because I can still see the third week now. Now I can see. Yeah, fourth week.
This is fifth week.
Okay, just a minute. Just hold on.
All five I have presented in the meeting itself, ma'am.
All five you have presented.
Here itself, yeah, ma'am.
Okay. Okay, got it. And the GitHub, just show me the GitHub. Chetan, is it all five have you presented in the session? I can remember about
Yeah,
three
yeah.
presentations. Okay,
No, ma'am. All five are presented in the session itself.
okay, fine.
And this is the GitHub. All five projects are in the GitHub.
Yeah, okay. Okay, fine, Chetan. Okay, you can just stop sharing.
Thank you.
Yeah. So guys from group 4, just drop me down the details like the all four of your names along with your mail IDs in the chat. Okay. So any one of you just try and like any one of you from your team just take in count that all four of your names should be there along with your possible mail ID like that where you are actually active in. Okay.
Yes, ma'am.
Yeah. So by the time, please drop down the text in the chat. So group 3, you are here.
Yes, ma'am.
Yes, ma'am.
Yeah. So guys, you can start your presentation.
Okay, ma'am.
Yeah, Varsha, you have anything to say, Varsha?
Yes, ma'am.
Yeah, tell.
Ma'am, I'm from group 6, ma'am. Today,
Okay.
today, two members of our team were unable to attend the session.
Group 6.
Yes,
Okay,
ma'am.
fine.
So,
Now we are going for group 3. You have time, don't worry.
okay, ma'am.
Yeah. You have anything else to say?
No, no, ma'am.
Okay, fine. You have time. If not today, tomorrow you can take off. Okay.
Yeah, ma'am. Okay.
Yeah. Lakshya, you have anything to say?
Yes, ma'am. I want to show you all the projects I have made and done everything.
Okay, Lakshya, you can just show me. Dishant, please, sorry, group 3, I'm really sorry. Group 3, guys, just wait for 2 minutes. I'll just check his one and then you can continue.
My screen is visible.
Yeah, yeah, your screen is visible.
I have uploaded all my projects on GitHub. As you can see, this facial clustering and the cybercrime, credit card fraud, and all that.
Say a bit louder, please. I can't hear you properly.
And I
Which is your
uploaded
first project, first week project?
credit card fraud detection.
Fraud detection. Okay. Second
Second is
week. Okay. Third one.
digit image clustering.
Okay. Fourth week.
Fourth is patient clustering.
The there is a spelling error there. Okay. Patient clustering. And last week, like the fifth week, which one is it?
Emotion detection.
Okay, fine. Okay. Just show me the mail ones.
System. Page mail.
Okay. So all you have done the video recordings, right? For all five?
Yes, ma'am.
Okay. Okay, Laksh. You can just stop sharing your screen.
Okay.
Yeah. Okay. Uh, okay, guys. So group 3, you can start off with your presentation.
Okay, ma'am. Is my screen visible?
Yeah, your screen is visible. You can start.
Okay, thank you, ma'am. Good evening, everyone. I am Sajruddin Alam, and along with my teammates Payal, Rekha, and Ria, we are excited to present our project titled Fraud Sense, an advancing fraud detection system. The primary objective of our project is to build an intelligent fraud detection system capable of identifying suspicious financial transactions using advanced machine learning algorithms and synthetic data generation techniques. For our research, we have used a Kaggle credit fraud data set, which consists of around 2 lakh transaction records with 24 key features. including both categorical and numerical attributes, such as transaction type, transaction amount, and account balance. However, one of the major challenges we faced was class imbalance. Only about 5% of the transactions were labeled as fraudulent, while the remaining was legitimate. This imbalance significantly affects the model ability to accurately detect fraudulent cases. To address this, we implement a series of data pre-processing techniques and incorporated synthetic data generation methods to enhance the dataset diversity and improve model performance, particularly in terms of recall. Each transaction was analyzed based on customer behavior, spending patterns, and device characteristics to identify unusual or suspicious activities. Through this project, our team's goal was to not just to improve fraud detection accuracy, but also to focus on data privacy, model scalability, and practical deployment. We built a Streamlit based user interface, which we will try to show you at the end of the project. Uh, with the Python pre-processing pipeline to demonstrate the complete fraud detection workflow, starting with the EDA analysis, which will be explained by the file. File, can you start?
Yes, yes. So we have imported all important libraries. Then we loaded the data set from Kaggle, that is
Payal,
bank
can you just
transaction.
start off again? In between, your voice was breaking. Just start off from the beginning, please.
Okay, ma'am.
Yeah.
So first we have imported all important libraries here. Then next we loaded our data set. So here is the overall structure of our data set. So this we have distributed our data set in two parts, 0 and 1. 0 shows the all non-fraud cases and 1 shows fraud cases. Here we can see the ratio of fraud and non-fraud cases. Next. So these are the column types of our data set. We have used categorical columns. So this is statistical analysis for fraud data and this is for non-fraud data. Next. So this is our first plot, that is class distribution. Here blue color shows this and red one shows the fraud cases.
Payal, your voice is breaking in between.
Here,
Is there any
so
network
here
issue?
is our
You start off explaining with this graph from the very beginning.
okay,
This
ma'am.
this plot, this pie chart, that one.
Okay. Okay, here blue color shows no non-fraud cases and red one shows fraud cases. Here we can see that non-fraud ratio of non-fraud cases is 95% and fraud cases are only 5.04%. Then next is box plot for transaction amount distribution by fraud. Here blue color shows non-fraud cases and red one shows fraud cases. This plot reveals that distribution of transaction amounts from both classes are similar, meaning the transaction amount alone isn't strong discriminator for fraud. Next. So next is bar chart for fraud by transaction type. This bar chart displays the fraud transaction type across the 5 categories. that is bill payment, credit, debit, transfer, and withdrawal. Here, blue color shows non-fraud cases and yellow color shows fraud cases. This chart primarily shows two things: high volume and fraud rate consistency. Here, all 5 transaction types have nearly equal high volume of transactions, each around 40,000 for non-fraud cases. And in every transaction type, the majority of transactions are non-fraud. So the proportion of fraud transactions, that is in yellow color, is extremely small in all 5 categories. This is the bar chart for fraud by device type. Here we can see that fraud is rare and equally distributed across the all device types like ATM, desktop, mobile, and POS. Next. So next is scatter plot for transaction amount versus account balance. So this plot shows that the data points are heavily scattered across the entire chart area, covering the full range of both account balance and transaction amount, like from 0 to 100K. Here, non-fraud cases are shown in dark blue color and fraud cases are shown in yellow color. Here we can see that, okay, this plot shows the fraud cases by state. So total transaction volume split between non-fraud in light blue color and fraud in red for every hour of the day. The hour of the day is not a useful factor for fraud detection because both total volume and number of fraud transactions do not significantly change throughout the day. So fraud is equally like at any hour. Next. Here we can see that this plot is distributed in 2 parts. Like this blue color shows the non-fraud cases and red one shows fraud cases. Here we can see that non-fraud cases are equally high in all hours and non-fraud cases are low as compared to, sorry, fraud cases are low as compared to non-fraud. Next. This plot shows the fraud percent by merchant category. The chart compares the fraud rate across 6 different merchant types like clothing, electronics, entertainment, groceries, health, and restaurant. Here, green color shows non-fraud cases and red one shows fraud cases. Here we can see that ratio of non-fraud cases is higher than fraud. Ratio of non-fraud cases is approximately 90, like around 94%, and non-fraud cases 5.2%. Next is transaction amount distribution, fraud versus normal. So here red color shows fraud cases and blue one shows normal cases. Here we can see that fraud and non-fraud cases got overlap. Next. So here is the box plot for transaction amount distribution for fraud versus non-fraud. Here blue color shows non-fraud cases and yellow one shows fraud cases. Here we can see that fraud versus non-fraud providing the exact statistical values for non all categories. So this also got overlap.
Next
Thank
will
you.
be the synthetic data analysis done by the Rekha.
Hello, good evening, ma'am. Ma'am, here we are import the libraries and then mounting the Google Drive, and after that set the data like original data and synthetic data path and the augmented data path, and then load the data. Here is analyzing the synthetic data, which is like basic characteristic of the data, which is shape of the data like 20,000 rows and 24 columns, and number of observation 20,000 and number of variable 24. Next. And the overall structure of the data set, here we have the total missing values are 0, and the target variables like is fraud. Here we have 30,433, and 0 is like 4,567, and the percentage of this here 86% and 13%. Next is class distribution. So in this class distribution, the fraud section is red and takes 87% of the chart, and the non-fraud section is in green that take 13% of the chart. The chart displaying on for the class distribution. Next. So in this original data, which is in the blue color, is relatively uniform with the some variation across the range 0 to 80K, and then the specific range of highlighting 64K to 67 with the 3956 transaction marked as original, and then synthetic data is in the orange color, which is showing the shape sharp peak at lowest transaction amount near 0, and distribution is skewed towards lower value and compared to the original data. Next. So in the original data graph, the graph has representing the different transaction type like credit, debit, bill payment, so on. And y-axis range is 0 to 40K, and transaction has highest count approx 39.953, and the second one is synthetic data. So the graph is showing in the x-axis like transaction types, and then y-axis transaction range from 0 to 9,000, and bill payment has significantly low count compared to the other transaction type. Next. So here in this part, the transaction amount versus account balance, original versus synthetic. So here we have the original data, and for the in the synthetic part, we have in the orange. Next. Now analyzing the augmented data. So in this pie chart, we can see the 85%, 82.8% are showing represent the total cases inside represented, which is in non-fraud, and the 17.2% are the fraud cases. So measure. Next.
Next will be the pre-processing part, which will also be explained by the Rekha.
So in this uh, file, we are starting with the like importing the necessary libraries. and then which is like pandas, numpy, sklearn, and then features like numerical features like age, transaction amount, and account balance, high credit card feature, uh, and transaction ID, merchant ID, categorical features like low credential categorical features, which is like the gender, state, transaction type, and date time features are like transaction date and transaction type. So transformation. So in this date time extractor extract the relevant features from date time column such as year, month, day, hour, and minute. Frequency encounter frequency encodes high credential features. Pre-processing pipeline. So in this numerical transformer inputs uh, numerical transformer inputs the missing value with modern and scales numeric features. High card transformer frequency encoder high coordinately features, and categorical transformer is inputs missing value with a constant value and the one hot encoding categorical feature. And date time transformer extract the data time feature and scales them. Preprocessor, a column transformer that combine the above pipeline for each feature group. So full pre-processing function. So it create a full pipeline with the preprocessor, fit the pipeline to the data and transforms it transform it, and then add an energized features that ratio of transaction amount and account balance, and transforming new data. It take a new data and a fitted pipeline, transform the data using the pipeline, add the energy features of the data in the application. So overall of this script provide a comprehensive data pre-processing pipeline for financial transaction data and handling various features type. Thank you. Next part.
Now, model training will be explained by me. Starting with the model training and evaluation parts. I have used different models such as logistic regression, decision tree, and gradient boost algorithms for my models for my training. Starting with my setup, as such, Rekha explained, she created a pre-processed pipeline. I have imported that pre-processing pipeline so that I can pre-process my data before training that. Pre-processing, starting with the original data, I have first checked the shape and extracted the labels from the original data and applied the pre-processing pipeline. Here I have used the fit process method so that the pre-processing pipeline learns from the original data. After that, like, this is my pre-processed data, which can be seen as some numbers. After that, on the augmented data, I did not use the fit process. Instead, I have used the transform process so that the pre-processing is done based on the original data, not on based on the synthetic data. So it not learns new values for the augmented data pre-processing. For the augmented data pre-processing, I have first shuffled the data as the for the recombining of synthetic and original data. The all the fraud cases were at the bottom of the data set, so that I have reshuffled so it combines all the data properly. And after that, I have applied the pre-processing transform pipeline. Starting with the model development, I have created a dictionary so that all the models can be applied in a single for loop or a pipeline, we can say. Starting with linear models, I've used logistic regression with some parameters, SDG classifier. Tree-based, I have used DD, decision tree, balanced random forest, as random forest was not giving a good result, I have used a balanced random forest. After that, gradient boosting, I have used XGB, light, LGBM, and cat boost. This function is for training process. After that, I have created a evaluation model function, which helps in evaluating the metrics. This function is for helping in getting the best model at the last so that we can save that model as a PKL file. Training on the original dataset, starting with the after completing the training, this is the result of the original dataset, which can be displayed in the form of plotting from here. We can see that from here, in the cases of classifier like fraud and non-fraud, our main focus is on the precision, recall, and F1. From here, we can see that the precision is very low, 5%, ranging around 5% for all the classifiers, except for XGB, which gives around 8%. 8% result for precision. While the recall, which is the most important for a fraudulent dataset classifier, recall tells us how many actual how many fraud datas were detected. From here, we can see that the SGD gives the highest result with 71%. Even that is very low for a recall. And here we can see that the SGB, which gives the best precision for the original data, here gives very low to zero for recall. So that from here we can see that original data was not able to handle the training, was not very good on the original data. To improve that, we have used the augmented data here, starting with the augmented training and after that plotting the metrics. From here, we can see that the precision has highly improved from the previous graphs, from ranging improving from 8% to around 17%. Our main focus was on the recall. From here, we can see that the cat boost gives us the highest recall, that is the highest number of captures of fraud data, 88%, meaning that the cat boost will capture 88 out of 100 fraud data, leaving only 12 fraud data or 12% fraud data, which also gives us the highest F1 rate. For I wanted to improve my model so that precision could be high for the cat boost model. So for that, I have used hyperparameter tuning to improve performance. I have selected the top three models, that is cat boost, SGB boost, and light GBM, to improve to get the hyperparameters for their best performances. Here I have defined the hyperparameter grid for the three models. After that, I have defined the models and I have used the randomized search CV to get the best hyperparameters for the given models. Here we can see that the for the best XGB estimators is 200, max depth is 10, and learning rate is 0.1. For LGM is number of leaves is 31, estimators is around 100, max depth is 10, learning rate is 0.01, and class weight is balanced. I have to interrupt this cell as it was taking too much time for the cat boost. I have explicitly defined the cat boost best parameters after finding some trainings on other datasets. From here, I have defined the cat boost parameters. After that, I have retrained the model on the hyperparameter tunes, from which I get the result this. From here, we can see that the cat boost recall is improved significantly from 88% to 99%, meaning that it captures 99% fraud data without only missing a single value. But from the other models, we can see that the XGB is highly reduced as it gives zero recall and F1, leading to zero recall and F1. LGM is still improved from its previous results, with 62% recall and 17% precision. Because of the high imbalance, precision cannot be increased further even after hyperparameter tuning. After that, I have checked the class weights and tried to improve further CAD model for the precision. But even after that, I have used the flagging method to uh, select the top 35% data here. I can show you top 35% data for the flag transaction. But even after that, the accuracy and precision was so low. even reducing from the previous results. So I have leave it as. I have also tried to building a deep learning model, a sequential model, to see that if it can improve my precision result. But even after using the deep learning model, there was not significant increase in precision as from we can see from here. For the fraudulent data, that is one, it is still giving 17.2% precision and 99% recall accuracy. So from all the models, I have saved the cat boost models. This is have I have commented out for as I have to do some other work. From here, I have selected the best model from the upper accuracies, which was my cat boost. I have also saved my pre-processing pipeline so that when I input a new data during the deployment, it can be pre-processed using that pipeline and can be used to predict new data, new results. I have saved two models. One is the best model with the cat boost without a hyperparameter tuning, and one is the cat boost with hyperparameter tuning, which gives us the 99% result. As if we want to reduce the overfitting, we can use the 88% result model. With this, I finished my model training. Deployment work is handled by the RIA. RIA will explain the deployment work. RIA, can you
Yes.
start?
Yes, so now I will explain my final fraud detection system web application, which I built using Streamlit for the user interface and a trained machine learning model for prediction. The goal of this app is to detect whether a given bank transaction is fraudulent or legitimate based on multiple input parameters. So first I import Python libraries such as Streamlit, Pandas, Joblib, Datetime, and Plotly. Streamlit helps me to create this interactive web-based dashboard. Pandas is used for handling and processing tabular data. Joblib allows me to load my pre-trained model and pre-processing pipeline files. And date time and time help in capturing the date and time of transactions. Here, Plotly is used for building the beautiful interactive God chart that visually displays the fraud risk level. After importing the libraries, the app loads. Yes, so after importing the libraries, the app loads the two main component, the train model file, that is the best augmented pkl, and the pre-processing pipeline file, that is the pre-process pipeline pkl. These two files were generated during the model training phase done by Sajruddin. So the pre-processing pipeline ensures that the user data is converted into the same format that the model expects. If these files are missing, the app will show an error message. This helps prevent the system from crashing unexpectedly. Then I configured, please scroll down. Then I configured the Yes, then I configured the Streamlit page settings where I set the title and the layout. Uh, the title is displays at the top of the app, that is fraud detection system, followed by a short description that tells user they can check whether a transaction is fraudulent or not using the trained ML model. So in the sidebar, I have included an about section that explains the two main working modes of the app, that is single prediction mode and the other one is bulk upload mode. Below I have headed a very useful control, the fraud risk threshold slider. This allows the user to decide how strict or lenient the fraud detection should be. Let's say if I set the threshold to 55%, it means any transaction that has a fraud probability higher than 55% will be marked as fraudulent. This makes the app flexible for different risk scenarios. For instance, banks can choose a higher threshold to reduce false alarms. Now, one of most visually appealing parts of my app is the God chart. Yes, scroll. Yes. God chart built using Plotly. This chart acts like a speedometer and shows how risky a transaction is. The dials moves from 0 to 100 divided into three colored regions. Like green is for low risk, yellow is for medium risk, and here red is for high risk. So when the model predicts a transaction, the chart updates dynamically and gives a clear visuals of the fraud risk. And now the app asks the user to choose the mode of operations. So either the mode of operation is single transactions or the bulk upload. In single transaction mode, I divided the input form into three expandable sections to make it clean. So first, yes, mode selection, yes. So first one is single transaction mode. I divided the input into like to first to select like customer informations where we collect customer details. uh, Please scroll. Yes, customer details like ID, name, gender, age, and location. Account and bank information like account type, balance, and bank branch. Transaction details which records like information, sorry, transactions ID, date, time, type, and device used. So once user fills the details and clicks the button predict fraud, the app takes all the input and converts them into a data frame format using pandas. Then it passes the data through the pre-processing pipeline, which applies all necessary transformations like encoding categorical values and scaling numerical ones exactly. Uh, After pre-processing, the model generates two key outputs. First, f- the fraud probability, like which shows the transaction being fraudulent or not. Uh, if the transaction is fraudulent, the system shows a red alert and a warning message like fraudulent detected. Uh, if it is a legitimate transaction, it shows a green success message. Yes, like legit transactions, and with along with a risk factor like 15%, 50%. So along with that, the God chart, please scroll down. The God chart. Yes, so uh, if the user want to test multiple transactions together, they can also switch to a bulk mode. Here the legitimate, the transaction is legitimate or the transaction is fraud, it is shown in the God chart itself. So if the user want to test multiple transactions together, so they can switch to the bulk mode. The here the app allows uploading either a CSV or Excel file. Once the file is uploaded, yes, once the file is uploaded, the app shows a preview of the data. And when user like clicks on the predict fraud, then the app pre-process the entire data set and predict fraud risky for every record. So yeah, that's all, and the next part will be continued by Sajruddin.
Now I will demonstrate how the fraud detection is working with the UI. From here, we can see that this is single transaction and bulk upload option, which was explained by the RIA. From here, we can, I have already set some parameters here. When we use the prediction model, then it will give us a fraudulent risk along with the risk factor. From here, we can also set the threshold as that we can increase it to 60%. Then using the, again, it is 64% here. It will tell how much percentage it is in up from the threshold or low from the threshold. If we change the parameters, like now it is giving legitimate transaction. We can also use the bulk upload. For that, I have used a original data set. I have created a subset from the original data set to check the function of the to check the accuracy of our project. Here I have uploaded the CSV file and used the predict function. From the 1000 transactions, 512 are fraudulent and 488 are legitimate at the 55% threshold. Uh, I can tell that this is very much high accuracy as the out of 1000 transaction, there are actual 500 fraudulent transactions which I have selected from the original. Here we can see at last it gives us the prediction that is either it is fraud or not, and along with the fraud probability, which helps in selecting whether it is a false alarm or an actual alarm. With this, we complete our code demonstration. Next report demonstration is done by, will be done by Ria and Pyle.
Just a minute, Sajiruddin. Can you just show me the code once? And there you have just saved the file, like the best model that you have saved. Just go to that section once.
Ma'am, model saving.
Yeah, model saving in the code, in the collab
Okay,
file.
okay, ma'am. This is the part.
Yeah, make sure that you remove this text and all. This blue text that you get, just remove those because that gives an outer prediction that you have just taken it the entire code from somewhere, like maybe Chat GPT or somewhat.
Okay, ma'am.
So just
Okay, ma'am.
remove this parts. Okay.
Okay,
And
ma'am. No problem.
also in the section like where you have done the app build, where you are not just going ahead with this section, some of the sections where this parts are this emojis are available, that is showcasing in the app, like in the header and stuff, that is fine. If that is not showcasing in that section, just remove this emojis, right?
No, ma'am. All the emojis are showing in the UI part. I can show
all
that.
the all the show all of that is
Yes,
showing.
ma'am.
If it is showing, that is fine. If
Yes,
somewhat
ma'am.
in some areas that is not showing, then just remove that, right?
Okay, ma'am. Okay, ma'am. That's no
Okay,
problem.
okay, fine. Okay, you can just go ahead with the report and the PPT section.
Okay, ma'am. Report. Ria will be sharing the report file. I will stop screen sharing.
Okay, fine.
Is my screen visible?
Yes, visible.
So I am Payal. I'll be covering the first part, including the abstract problem statement, system architecture, and tools. So here is the abstract. Our project focuses on detecting fraud banking transactions using machine learning and deep learning. With the rapid increase in digital payments, traditional rule-based systems often fail to catch modern hidden fraud patterns. So we use the dataset with features like transaction amount, type, device, merchant, and location to deal with immediate fraud. data. Since fraud cases are very few, we use smart and synthetic data generation to balance it. Then we train models like decision tree, logistic regression, random forest, light GBM, XGBoost, CatBoost, and neural networks using focal loss. Finally, we compared the performance using metrics like accuracy, precision, recall, and F1 score, and saved the best model for each deployment. Next. So here is the introduction of our project. So in today's digital world, millions of transactions happens daily, but that also increases the risk of online fraud. So fraud detection is difficult because fraud transactions look similar to genuine ones. So we use AI to detect fraud early and prevent fraud before it happens.
Hello, your voice is not coming. Can you, Ria, you are just muted.
Ma'am, she is Payal.
Okay, but Ria is presenting, right?
No, ma'am, Payal is presenting.
But I can't see
Yes,
here.
yes.
It's showing Ria.
Screen share is done by Ria. Explanation is done by Payal right now.
Okay, fine, but I'm not getting your voice. That's why I asked.
Okay, ma'am. Introduction slide. Okay. So main challenge was class imbalance. Very few fraud among a large number of genuine transactions. So handling that was key part of our work. Next. So here is the problem statement. So manual and rule-based fraud detection methods are slow and often miss complex frauds. Some of the major challenges we address include imbalanced data set, like very few fraud cases are there, and complex patterns. Fraud can depend on multiple factors like amount, time, and device. Then proper evaluation metric. That accuracy alone isn't enough, so we use F1 score and recall. Then realistic deployment. The model should work on both original and synthetic data. So our SIS focuses on overcoming these challenges using data pre-processing, augmentation, and model optimization. Next. Yeah, next slide. So our main objectives were EDA, handle imbalance using smart and synthetic data, train and compare ML and DL models, optimize model using hyperparameter tuning, save the best model for deployment, and provide visual insights like fraud by state or transaction type. So in short, we wanted a complete end-to-end fraud detection pipeline. Next. Next. Yeah, next slide. Next slide.
Ria, are you there?
Guys, what is happening?
Yes, I am scrolling the next slide, Pile. Is my screen not visible?
Its your screen is stuck at single background study.
Okay.
Open the background study slide.
Ria, you can stop. I will share the report.
Okay, okay, sorry.
Payal, from which slide you have to start? Background study or from the next?
Background study.
Okay, you can continue. Is my screen visible or not?
Yes, it is
Next,
visible.
modern fraud patterns are more complex. So now machine learning models like logistic regression, decision tree, and random forest are used automatically to learn patterns, boosting algorithms such as LightGBM, XGBoost, and CatBoost to improve performance on imbalanced data. So we also implemented a deep learning neural network with low focal loss, which helps the model focus more on minority like fraud cases. So by combining both ML and DL techniques, our project achieves better accuracy and reliability. Next. So next is system architecture. Here's the step-by-step workflow of our project: data collection, pre-processing, EDA, augmentation, model training, evaluation, and model saving. So this pipeline converts raw banking data into a ready-to-use fraud detection model. Next. So we use full Python-based environment. Python for main programming language, Pandas and NumPy for data handling, Matplotlib, Seaborn and Plotly for visualization, scikit-learn, LightGBM, XGBoost and CatBoost for machine learning, then TensorFlow and Keras for deep learning, then Joblib and H5 for saving train models. So this tools help us to manage large data set and train models efficiency.
Kyle, your voice is
Next.
breaking. Your voice is breaking in between.
Okay, ma'am.
Just repeat the last section more.
Okay, ma'am. From tools and technologies.
Yeah, just go ahead with it.
Okay. So we use full Python-based environment, Python for main programming language, Pandas and NumPy for data handling, Matplotlib, Seaborn, Plotly for visualization, scikit-learn, LightGBM, XGBoost, and CatBoost for machine learning, TensorFlow and Keras for deep learning, then Google Colab for development with GPU support, then Joblib and H5 for saving train models. So these tools help us to manage large data set and train models efficiently. Next, then we divided our model into system into six modules. First is
Your
data
voice is
drawing and
breaking.
exploration.
Your voice is
And
breaking. It's not properly audible. Your voice is breaking in between.
okay, ma'am. So we divided system into 6 modules. First one is data loading and exploration to read data sets and check for missing values. Then next is EDA for visualize fraud by amounts, data and time. Then pre-processing and augmentation to encode, scale and balance data. Then next is model training to train and tune different ML models. Then deep learning model to build neural network with focal loss. And last is evaluation and deployment to compare models and save best one. So these models form a complete workflow from raw data to final fraud detection. So in data loading, next we first loaded the original bank transaction data set and an additional synthetic data set that we improve balance between fraud and non-fraud cases.
Payal,
So we
your
perform
voice is
visual
breaking. See, Payal, your voice is breaking in between. It's I cannot get in through with this things because every time you're trying and speaking, after a minute, your voice is starting to break. So, so it's difficult to understand all of
okay,
it,
ma'am.
right? So, Sajiruddin, can you
Okay.
just take it up from here and start with the explanation?
Okay, ma'am, no problem.
Okay.
Starting with the ma'am, start with feature description or from the next?
Yeah, you go with features description.
Okay, ma'am, no problem. Starting with the feature description, starting with the first module. Module 1 tells us about the data loading and exploration part. We have loaded the original and synthetic data and combined them to get the augmented data. Check for missing values, duplicate, and basic statistics. After that, perform EDA to get the idea of the get the insights from the original data and compare that with the synthetic data so that we can check whether both the data are uh, comparable or usable or not. As synthetic data, sometimes it is totally different from the original data. For that, we have used ED on both the data sets. Here we are showing some graphs which we have already explained in the EDA section, starting with the box plot, which tells us median, IQR, and whiskers and outliers for the transactions amount. After that, fraud data distribution by state, transaction amount distribution, which tells us that both the transaction fraud and non-fraud transactions are similar to each other and are overlapping. After that, the module 3 tells us about the pre-processing and augmentation. Pre-processing parts include converting the categorical data into numerical data using encoders, normalizing numerical features, applying smart and different synthetic techniques for fraud cases generation, and combining original and synthetic data set. In model training, it trains different multiple ML models along with DL models. ML models include light GBM, XGB boost, CAT boost, and classical models like decision tree logistic regression. After that, we have applied the randomized search CV for hyperparameter tuning for finding the best parameters for the CAT boost, XG boost, and light GBM. From here, we can see the training accuracy on original data set and on the augmented data set. As we can see that with the augmented data, the recall and precision have improved very uh, statistically. Augmented data models gives the with the best F1 score of 0.2928 of CAT boost and XGB boost. These models are highly sensitive to fraudulent cases, which means they are having high recall values as they are able to tell the fraud data from the non-fraud data. After that, we have saved the best models that was CAT boost with the F1 score of 0.28. Uh, I have also built a deep learning model to check the to improve the precision with the focal loss, but there was not much improvement on that, so that we have dropped that model. Evaluations on the on evaluation was done on different models to compare them and get the best model, from which we get the CAT boost model. and it was saved using joblib. Here, this shows different PCA projections on the synthetic and augmented data to see their distribution among them. This is our front end view UI displayation and some of the limitations done by step. The biggest limitation of our this was implementation, which I have already explained in the feature section along with the module explanation. Observations, we can see that the deep learning model with focal loss achieved the best F1 score, but it was having a very low precision, so that we have not choose that model. Assemble models improve detection of minority classes compared to single ML models. Limitations, we have used a smart technique, but it was giving a 0 to 1% result on precision for precision recall. So we have removed that. Real-time streaming of transaction not implemented. For future enhancement, we can use APIs for banking applications, include a shape and line model for model interpreting. Graph neural networks could help in improving the precision and fraudulent patterns, and including multiple sources of data, so that to improve the overall data of for the fraudulent cases. In conclusion, we will say that the our overall model was able to detect the fraud cases, which was the main purpose of the model, with a higher accuracy of 99.2% of recall. Uh, with little improvement, it can also handle the precision. It can also handle the non-fraudulent data, so that the precision can be improved. With this, we conclude our report file.
Okay, okay, Sajuddin. You can just have you just shared the PPT as well?
No, ma'am, PPT section is left.
Yeah, so share the PPT and just go like in a random way, just like not in a like jumping from here and there. Just go very short and simple. You don't have to explain everything.
Okay, ma'am. PPT is done by the Rekha. Rekha will explain in short.
Fine.
Rekha, I am stopping my screen sharing. You can share the screen.
Okay. Is my screen visible?
Yeah, it is visible.
So, in this project we are focusing on advancing fraud detection in banking transaction using CityGAN based on synthetic data. It addresses challenges like rare fraudulent transaction and imbalanced dataset by generating realistic fraud samples. So, this is the project flow, like abstract, introduction, and so on. And then in the abstract we are uh, like meaning in short, it involves pre-processing data, performing EDA undercover pattern, and then handling class imbalance and CityGAN for using CityGAN for realistic synthetic fraud samples. And classification models are trained, evaluated with the robust matrices and visualize. Next, introduction. So, in this, finance fraud detection is major challenge due to the rarity of the fraudulent transactions loading to the class imbalance in data set. Next is the problem statement. Uh, like in this project, clean and balanced banking data using CityGAN and pre-processing techniques, it train model to accurate detect fraud and visualize the transaction pattern and model performance. And objective are like data pre-processing, like in for the bank transaction data set, and then EDA understand data patterns, and next is synthetic data generation and model training, visualization, deployment, presentation. This is the flow of the project, which is environment setup, data set, database initialization, synthetic data generation, cooperative, and so on. Next, scope of the work. So in this, we are doing data pre-processing, uh, EDA, synthetic data generation, model training, and visualization. Tools and techniques are programming languages Python, and these are the libraries and environment and techniques we are used here, which is data cleaning, encoding, and mm, so on. And then methodology, we are using here data pre-processing first, handling missing values using a simple imputer, and then scaling numeric columns, and encode categorical data, and extract new date time features, and then next EDA part, and then synthetic data generation using the CTN, and model training and visualization. Outcome of this project is it clean and pre-processed data ready for the modeling and balanced data set with the realistic fraud samples. And this is the implementation algorithms, which are CAD boost, XGBoost, light GBM, logistic regression, SGD classifier, and balanced random forest. EDA visualization. This is the class distribution. This is for transaction amount distribution graph, and this is for fraud by state graph, and for transaction amount distribution graph between fraud and non-fraud, and this is for compare class distribution, and that is for feature distribution comparison for the transaction amount and for the age. This is dimensionality visualization using the PCA. This is our UI part, like output part. The performance of the our project is like CAD Boost with the score 28.6, and XGBoost achieve highest F1, and the result for this is best model is CAD Boost, which is with the F1 score 28.68%, and the precision is 85.28%, and recall is 0.1%. The conclusion of this project is like this project analyze banking transaction to detect fraud using data exploration and synthetic augmentation. The insight help financial institute prevent fraud, reduce losses, and build customer trust. These are the reference. Thank you, ma'am.
Okay, you can just stop your screen sharing. So I just wanted to ask, in your group, there are 5 people, right? 5 people allocated. But Southern Vikram, I didn't get any of the update from him. Didn't he like stayed with you for the project, or what is the issue with him?
Ma'am, he told us that he was dropping from the internship as he
Okay.
was having some personal issue.
Okay, fine. Okay, so 4 of you in the same group, right? In group 3.
Yes, ma'am.
Okay, so I'll just call out each one of your name. You just show me the GitHub repository along with that, along with the mail that you have shared. Okay,
Okay, ma'am.
yeah. So Payal, just show me the details from your end.
Okay, ma'am. Wait.
And guys, by the time everyone is sharing from your team, just like from your group, any one of you just mention you like all four of your names along with their proper, like the whole name, that is the whole name, along with the mail ID of yours, proper working mail ID. Just share me
Okay,
that.
ma'am.
Fine?
I'm doing that.
Yeah. Yeah. Do it in the chat. And by the time Payal, just show me the details.
Ma'am, I have some work. Can I leave the meeting?
Just wait some time. I need to do some of the, I need to just ask some of the details. So just wait, Varsha.
Okay, ma'am.
Yeah. Payal, these are your repositories, right?
Yes, ma'am.
Okay. So just show me like which project that you have taken into consideration.
This is project like week 1 project,
Which one? That is
cyber
cyber
attack
attack.
transfer.
Okay. Then.
Week 2, e-commerce user behavior segmentation.
Mm-hmm.
Week 3, credit card fraud detection.
Okay.
Week 4, movie lens user clustering.
Okay.
Week 5, student performance prediction.
Okay.
And week 6, fraud detection. This one.
Okay. Fine. Got it. And show me the mail. File, you have not shared the entire screen, so you need to switch, I guess. Can you hear me? Am I audible, guys?
Yes,
Yes,
ma'am.
ma'am.
I think Payal is having
Yes,
some
ma'am.
network issue.
Okay. Sajidin, did you just drop the details?
No, ma'am, I'm writing.
Okay, fine. Can you ask Payal to just rejoin if possible?
Okay, ma'am.
Yeah, Rekha, you're here.
Yes, ma'am.
Can you just show me your details once, like the GitHub and the mails?
Yes, ma'am. Is my screen visible, ma'am?
Yeah, your screen is visible.
So this is my mini projects list. Like this is the week 1 project. This is for second, third, fourth, and 5. And this is major project.
Okay, fine. Got it. So you show me the mail ones.
Yes, ma'am. This is for first week and second week, third week, fourth, 5, and 6. Ma'am, I
Okay.
have shared the video in the link, like form link, not in the some of the project in here. So I will attach them after some, like after this.
No, no. I asked you to share the videos in the mail only, right? You have to share the details in the mail.
Okay, okay, ma'am. I will add
Uh,
this. I
like I just want to see some of the videos that you have taken into consideration. Just show me the videos that you have prepared.
here I have share already. Like I always I am like present the uh, project in the live session, but one or two I need to send the like
Rika, is it like
not
that that you have presented in the session? I don't remember that you have presented in the sessions.
third week
See,
I have not present, and fourth
No, no.
I'm not properly
See,
remember that five
I
fourth
can't
are
recall that you have actually presented in the session. Since
okay,
those
ma'am.
who have actually presented, I try and recall their name, but I can't recall that you have presented. But see, that would be the evaluation section. If you are thinking that you are telling that you have presented in the session, everything will be evaluated, right? So you need to check on. So any of the present, like you told you have made some of the recordings. So what recordings you have prepared? Just tell me, just show me.
Uh, Wait, I have added in the drive. Um, Maybe some of these are in between. I'm not remember properly, ma'am. After
Okay,
this,
fine, fine.
I will
After
share
this, you
them.
just share it. Fine. Okay, okay, Rekha.
Okay, ma'am.
Okay, just a moment. Next is Ria. Ria, you're here.
Yes, ma'am.
So can you just show me the details?
Yes, ma'am. So is my screen visible, ma'am?
Yeah, it is
Yeah,
visible.
it is visible. Yes, ma'am. So this is my week one, week two, week three. Sorry, week one, week two, week three, week four, and week five project.
Okay.
Okay. This is the mail, and ma'am, I have submitted the video recording link. Like, this is my
Okay. Okay.
link of collab and link of presentation.
Okay. Got
Okay,
it. Got
all
it.
five,
So
all
can
five,
you?
ma'am.
Okay, got
Okay,
it. Can
got
you
it.
just
Can you
show
just
me
show
your
me your
recording once?
recording
Any
once?
of the
Any of the
recording that you
recording
have
that you have
prepared?
prepared? Yes, ma'am. Yes, ma'am. Ma'am, like this.
Okay, okay,
Okay.
fine.
So, hello everyone.
Okay, Dia, you
Okay,
can
Riya,
just
you
stop
can just
sharing your screen.
stop sharing your screen. Okay, ma'am. Ma'am, wait a minute. Thank you, ma'am.
Yeah. Sajiruddin,
Yes, ma'am.
can you just share me the details?
I'm waiting for the Rekha to share her email ID. Rest of the
No,
students have shared.
I understood. I am asking about the mail and the GitHub.
Okay, ma'am. Sorry. Ma'am, this is my mail. Actually, I have first submitted the first project by mail and the rest of the by form. So I have again submitted all together in a single mail.
Okay, you have also attached the recording. Okay, you have just shared in like presented in the session, right?
Except for the first one, which I have recorded a session and it is available in the same drive where the more codes are available, projects are
Okay, you
available.
have shared
It should
the
be here.
drive link, right?
Yes, ma'am. There it is, week one presentation, which was I
Okay.
was not able to attend.
So it would be better if you can just attach it in the mail and reshare it. And can you just show me this week one presentation once?
Week one presentation. Okay, ma'am.
Just open the file. Okay, fine.
Yeah.
Okay, Sajiruddin. That's fine. Okay. So by the time other details, like you have shared the mail also, and just show me the GitHub ones.
Okay, ma'am. Get up. 1 minute, here, here it is. Ma'am, my first 5 week project are in a single folder. This contains first
Okay.
5 week projects.
Okay.
Here are the files and here are the details.
Okay. Okay, Sajiruddin. Okay, got it. Fine. So,
Okay.
Did Rekha shared you with the mail ID? If not, you can share with whom you have got. Just share with that.
Ma'am, Rekha has shared. I am just writing it.
Okay, fine. Okay. You can just stop sharing the screen and share me the details.
Excuse me, ma'am.
Ma'am,
Yeah.
Ma'am, my name on the list, like you shared the document on the group, so my name on the list is not correct. So can you please confirm me that you have write the right name of mine?
Where I didn't get you. Can you come again? I just missed out what you actually do.
Ma'am, the one document in the group has been shared, and my name on the list is not right. So can you confirm me with my name, like if it's right?
Which list? Which list?
Like the team name document file shared in the group, WhatsApp group.
It's Rekha Kumari, right?
No, ma'am, it's Riya Rawat.
Okay, sorry, your name. Okay, Riya
Yes,
Rawat.
ma'am.
Right, yes. I have taken down this name of yours.
Ma'am,
Okay, ma'am.
my name is also incorrect. Here, my after Bhil, there is a southern name written. That is not
Oh,
correct.
that is not correct because you people has only given me the total name, like the whole name in the first section. That has been taken only. Just a moment. The details that I am having, I'm sharing with you. Just a moment.
Ma'am, I have just shared all the correct names and email IDs of all the group members.
Okay, fine. Just a moment. So these are the details that I am actually having. So is it correct?
Ria name girl wrong. Ria's
Yes, ma'am,
name is
my name
wrong.
is not correct. It's RAWAT.
Okay, then I guess in from your group only the name when it has came up that was wrong. Then just a moment. RAWAT, right?
Yes, ma'am.
Okay, and what and others, is it correct? And for others,
Mine is
Yes,
correct.
ma'am.
okay. Rekha, is it correct?
Yes, yes, ma'am.
Okay, fine. Okay,
ma'am,
fine.
can I show again from GitHub?
Uh, Payal, right? Yeah, yeah, Payal,
Yes.
you can show me the details.
Okay.
So, have you just mailed them the details? You told me about the mail. Have you just mailed the details?
Yes, ma'am.
Okay, just show me once.
Okay, ma'am. Pick one GitHub link, presentation.
Your voice is breaking. Just a moment. Yeah.
Week 3,
Mm-hmm.
week 4, 5, and week 6.
Okay. So, can you just show me the presentations, the video ones, any of them, like how you have taken in to?
Okay. Sorry, ma'am.
I can't see it. Okay, do one thing, Payal. There is some network issue in your, there is some network issue from your end. Just fix the issue and tomorrow you just show me the details, okay?
1 minute.
Okay. You share me the
Okay, ma'am.
details tomorrow. Fine. Okay. And guys, I
Okay, ma'am.
guess a link has been given, a feedback link has been given to you for in the WhatsApp group. So I was talking about that. You just share the feedback link there, and there should be a video feedback should be there. So just go ahead with that and share the feedback. Okay. I guess a feedback link has been given to you, right, guys, in the WhatsApp?
Yes, ma'am.
Yes,
Yeah,
ma'am.
ma'am.
So just go ahead and do a propose for all of you, not for group three. I am saying for everyone. Okay, just a feedback link has been shared in your respective group. So kindly just share a video feedback as it was mandatory. It is very much mandatory for the certification. So you need to share a video feedback of that. Fine.
Okay, ma'am.
Yeah, and the group three guys, last I have given you the names, so these are correct, right, guys? Except Ria Rawat, that is RAWAT, right? The details
Yes,
are
ma'am.
fine, right? So I'm just taking down this names. Fine.
Okay, ma'am.
Ma'am, is it visible now?
Yeah, it is visible.
So this is week 4 presentation.
Okay, okay, fine. Okay, Ria. Sorry, okay, Payal. I'm really sorry. Okay, Payal.
Okay, ma'am.
So yeah, you have taken down the also mailed everything from first week to fifth week, all of the project you have mailed along with this videos, right?
Yes, ma'am.
Okay. Okay, fine. Guys, you can leave. Tomorrow we will be meeting and accordingly we can move on. Fine?
Ma'am, I have
Okay,
a
ma'am.
doubt.
Yeah, Aditi, tell.
Ma'am, it is actually told us in the official group that the feedback we need to make a video. So
Yes,
we need to make a video or just voice message of three to
it would
four
be a
minutes.
video. No, no, it has been mentioned video, so go with the video.
Okay, ma'am.
Okay. And
Yeah.
I just ask you, you're from group one. Laksha is in your group, right?
Yes, ma'am.
So please mention him in the group from in your group where you are connected that he needs to be like he needs to just come down in tomorrow's session positively. Fine.
Okay, ma'am. But yeah,
Just
now in this session, he has already shown you everything.
yes, but there is certain things that I need to check on because the video presentation that he has given that is not proper. That's why I need to just ask him. Fine.
Okay, ma'am. Yeah, yeah, sure.
You just you don't have to just go into details about it, but just ask him that he have to join tomorrow's session positively without fail, because if he is failing to do that, he will be not getting the certificate. Fine.
Okay, ma'am.
Okay. Okay, guys, you can just leave and make sure that you share, like whoever has done with the presentation and the other details, please make sure to do share the feedback. Right? The feedback details has been given, so you can just share the feedback. Right? Bye, guys. Thank you.
Bye,
Bye,
ma'am.
ma'am.
Thank
Thank
you,
you,
ma'am.
ma'am.
Ma'am, my question is balanced. Sorry, ma'am, interrupt you.
Yeah.
Hello. Ma'am, I'm
Yes.
Ranvijay. You did told me we'll discuss in the letter. So shall we discuss today,
Yeah.
tomorrow?
I can we just discuss tomorrow, please?
Okay, no
You can
problem,
try
ma'am. No problem. Thank you.
from your end if that is suiting it up. That's fine. If not, please be available tomorrow. Tomorrow we can discuss because tomorrow is the last session for the presentation. Also, you have to present it tomorrow somehow. You check it. If it
Ma'am,
is
I can
not
present you.
possible,
I can present you, ma'am. I already 5 projects submitted, 6 project. I already done it. Only the part is deployment. Deployment is balance. That's why we are unable to
okay,
create
okay,
the
fine,
PPT
fine.
and this
I
one.
understand. Okay, I
Okay,
understand.
no
So
problem, ma'am.
tomorrow we can definitely discuss. If tomorrow you are the only person also, I'll see your presentation. Fine?
Okay, ma'am. Thank you.
Okay, okay.
Ma'am,
Thank you. Yeah.
ma'am, in the official group, they have mentioned that today is the last day for major project presentation. That's why I have asked you.
No. Tomorrow will be there because the students are more and it is taking time for the presentation. Tomorrow will be there for the presentation. Fine. Don't worry.
Okay, ma'am.
Okay,
Thank you.
Varsha. And
Yes,
tomorrow, you are in which group, Varsha?
sixth group, ma'am.
So tomorrow there would be your presentation. So come prepared. Fine.
Okay, ma'am.
Yeah. Okay, fine. Bye, guys. Guys, you can leave. और नींद आ रहा हो